If you look at the IPS and IDS, these are other services that actually allows you, or you can say another important key feature in the branch security, and a component of the security suite, that an IDS or IPS can inspect traffic in real time in order to detect and prevent cyber attacks by comparing the application behavior against the known database of threat signatures. So how it works is when the you can say IDS and IPS are set up, then they already have a database of the recognized threats in all around the world, or in the cybersecurity framework or so. If a traffic comes up, right, when a traffic actually comes up to the IDS, and when that particular traffic hits to the database, and if that is matched with one of the threads, then the traffic is definitely going to be dropped. But this is a collaborative work done by IDS and IPS both.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So IDS actually detects whether the traffic is malicious or not. And if it is found malicious, then it tells the IPS to take appropriate action against that. Right? That's how the behavior actually set. And once the IDS IPS can notify that particular network operator as well through syslog events and dashboard alerts, as well as it can stop the attack by blocking the threatening traffic flow. So the enablement of IDS and IPS is done through the use of iOS XE. iOS XE, I think containers. So what iOS XE allows you is there is a hypervisor that has been set on the iOS XE platforms. That hypervisor is called as KVM, and this particular KVM hypervisor can actually host a Linux machine based on that. So you can use Linux as an application over there. And this particular Linux needs to be dedicated with the hardware resource definitely. If you go with the service provider courses, you will get to know about how you can use this particular stuff in there. So when you go through this particular installation, you can definitely use Python on the box. You can definitely use all the Linux utilities that can be that can benefit you in terms of doing on-box programmability, or in terms of doing on-box security. So when you enable these applications, then the iOS XE is going to allow you to install that particular IDS and IPS feature onto this particular box as an application only. And similarly, you just need to create an IPS and IDS policy. And when you configure that particular policy, you need to specify that this particular policy can actually use something in you can say helping you to save your traffic in a way. So that's how IDS and IPS actually helps you with. Then if you talk about something which is there in URL filtering, then in the URL filtering, is another like security function that actually leverages and allows you to allow your enterprise firewall, when you're going to have that. What this particular thing is going to do is the URL filtering engine kind of enforces acceptable controls to block or allow websites. So an admin can choose to permit or deny website based on different categories that are available. And the sites, you can say, there are, I would say, categories by using which your firewall can actually create scorecard, okay, for the enormous numbers of websites that are available there. Now, this is not done directly by the firewall. How it works is the firewall actually in talk with the Cisco's cloud service. And you need to purchase a service for that. But based on that particular cloud service, what's going to happen is that cloud service is going to help the firewall to score that particular website's reputation. So if the like score is good, and according to the website or according to the Cisco's cloud, because there are lots of other infrastructure as well that needs to be dedicated. So what Cisco does is Cisco is has lots of infrastructure to identify enormous amounts of websites that are available all over the globe. And similarly, when someone purchases the service from Cisco, Cisco integrates it with the firewall or integrates it with the next generation firewall, FTD, right? By using that particular firewall, it tells that particular firewall whether the traffic is good or not. So the FTD maintains the database of that in order to mark or unmark a specific website score. If there is some traffic that comes up to the FTD, which FTD does not know about, then FTD puts that particular traffic on hold, and then it lets the cloud application know about that. Hey there, I'm looking forward to know about the score of this particular website, that I'm not aware about how good it is or how bad it is. Can you please help me with that? So then cloud is going to perform like you can say a score reputation test, and based on that it will inform that particular FTD that whether the website is good or not, and based on that the future traffic is going to be allowed over there. That's how the scenario is done. So when an end user requests access to a particular website through their web browser, the URL filtering engine inspects the web traffic and first queries the any custom URL list if that's there. If the URL matches an entry with in the whitelist that has been allowed, because it maintains a blacklist and it maintains a whitelist. So if it's there in the whitelist, then it's going to allow the traffic. If the entry URL matches into the blacklist, then the access is denied with no further inspection. So when the access is denied, the end user can be redirected to a blog page with a customizable message that can just let the user know that, okay, you're trying to access something that shouldn't be accessed or so. So that's something that is available as URL filtering over there, which is again a customized service that can be taken by Cisco. So to support URL filtering functionality, your ISR series router or your you can say FTD needs to at least have 16 GB of RAM, right? Because it needs to maintain and perform lots of operations for the database lookup and all. So that's quite a requirement that is available there into the whatever firewall that you're putting or whatever router that you're configuring as a firewall itself, and having that particular service there. And after that, lastly, we have a feature which is called as AMP, Advanced Malware Protection. So the AMP is the latest and greatest, I would say, addition to the Cisco security portfolio. And with the as with the URL filtering, the AMP or Advanced Malware Protection, or there is another thing which is called as TG, Threat Grid. Right? This thread grid is again a new feature that has been added into the Cisco's portfolio. So AMP and TG, they both leverage kind of a snort engine, if you know what snort engine is. And this particular snort engine is going to inspect the file that are downloads that are downloaded onto the systems. Okay, and you can say they're going to detect the malwares into the real time. So AMP can block malware trying to enter into your network using antivirus detection engines and so. And one-to-one signature matching and all these other technologies are basically used in order to identify that when the traffic is actually flowing, when someone is trying to download anything, like maybe on a website, that website is actually allowed in the URL filtering. But whenever by using that website, if you're trying to download a file like xyz.exe, this particular file can be something that is malicious, right? So URL filtering is not going to help you with not downloading that particular thing. It's AMP or TG that's going to help you with that. So when you have AMP there, it actually checks the MD5 signature or checksums over there, and then it is basically identify whether the file is, you can say, intact or it has been tempered. If that file has been tempered, then the download will actually stop and it will not let your network, or it will not let the file enter in your network or so, and it will drop that particular traffic definitely. So even if the file is downloaded, then the snort file preprocessor, which is available into the engine only on the managed router, it actually identifies the file download and it computes the SHA-256 hashing, okay, for the file, and it looks it up in the local cache if to learn if it's a known good file or if it's a bad file based on the hash that it knows about. And if no match is found on the local database, then the hash is sent to the AMP cloud identification, right? Just like I told you over here. If there is no hashing that has been detected on the local engine, then the firewall or then your like managed router is going to send that to the AMP cloud, which is again a service hosted by Cisco. And the AMP cloud will identify whether the file is good or not. So if you receive a response which says clean, it means that the file downloaded is allowed, or the file download is allowed to complete, right? And if the response is malicious, then the file download is interrupted and stopped, and it will not let the download complete. And if it is unknown, then you can say the active content is actually, like, if that is unknown, and if the active content is found, then the managed router sends the file to another engine that is called as TG, thread grid. Okay, and the managed router sends that particular file to thread grid for sandboxing, and the managed router queries thread grid for a period of time, and then queries the AMP to you can say retrospection, and the thread grid then updates the new status of the hash into the AMP cloud. So it's going to let the AMP cloud know about the status, and then AMP will again tell that particular thing to the managed router that whether it's clean or malicious. That's how the scenario is done into AMP and TG. So this is used for you can say specifying how it can save the security, or how it can save the internal LAN traffic from not downloading malicious content on your site. So that's how you can say the security features can actually be inspected, or that's how these are the security features that are available into your I would say SD-WAN fabric, and these all are specified into the official books as well, and the steps to install them. 4 or 5 steps are available there, but definitely we cannot really test it into the lab that we have, because we're having managed clouds and we do not have FTDs and we do not have advanced firewalls installed into our labs and so on. So these are the security features that are available there. Questions?
So what is sandboxing?
Sandboxing is basically something that if you have your resource, maybe I have a CSR 1000V, and I do not want this particular CSR 1000V to be available on my local infrastructure. So what I can do is I can host it on a cloud application, maybe Azure or maybe AWS or so. And since I'm able to access that particular router from a remote location on a cross-platform environment, any operating system or something like that, I can just initiate an SSH connection. And by using that SSH connection, I can reach out to that CSR 1000V and fetch the details on. So I would call this particular environment as a sandbox, because it is not locally available. It is available on a cloud application, but I can access it just like a local access. We call it as a sandbox. So the thread grid infrastructure is not something that you install in your local environment. It is available into Cisco's data center. That's why we call it as a sandbox.
Okay.
Yep. All right.
What about SSL proxy?
SSL proxies are basically when you actually do so if you have lots and lots of traffic that is actually going out from source, like over here, this is outside traffic that is actually coming on your WAN edge maybe. Then on the WAN edge, there are lots of internal devices that actually needs to be allowed. This is internal and this is external. So your external traffic, when it hits in, you probably are trying, maybe there are web servers hosted. This is web server, this is email server, this is CRM, and this is ERP solution. So all of these particular services can be accessed by using HTTPS. How it's going to work is your When you use an HTTPS connection, when you configure the SSL proxy, your HTTPS session is terminated right over here. And then the Vantage actually creates a normal TCP session. So because in order to decrypt the SSL traffic, there are lots of processing that actually needs to be done. So we use proxies for SSL, that how these particular internal traffic can be treated to end up right over here. And then the Vantage can create an TCP flow for actually reaching out to the internal traffic and get a reply, and then again encrypt it and send it to the user. So the user assumes that it's having end-to-end SSL connectivity, but it is actually not, in order to save the internal processing of that. That's generally setting up a proxy for SSL also. These goes into the core security implementation when you actually work around with it. And that's how security infrastructure of Cisco can be looked into. Talking about the next thing, if you look at how QoS can be allowed. Then QoS, I would say, so there are network devices. QoS definitely stands for quality of service. And in this quality of, sorry for that. So in this particular quality of service, the network devices don't really care about the type of traffic they have to forward, right? Your switch probably receives an Ethernet frame, and it looks for the destination MAC address and forwards the frame towards the destination. And same things apply on your routers or apply on any other networking devices that does the forwarding of traffic, right? If it receives an IP packets or so. So it looks for the destination into the routing table and it forwards that particular traffic accordingly. Now, does the frame or does the packet contain data from a user trying to download the latest songs, maybe from Spotify, or it is like, or is it like doing an important speech traffic from voice over IP phone, right? Or it's doing an important conference by using some collaboration tools, maybe Cisco Finish or so, right? The switch router doesn't really care about that. So the forwarding logic is basically called as, and this is pure routing and switching, I would say. This is basically called done on the best effort basis. Or you can also call it as FIFO structure, right? First in, first out. So sometimes this can be an issue over there. You definitely might have some traffic that is actually going from your internal infrastructure. If you have a normal topology like this, right? And let's say there is a switch there, and the switch has a user, and the switch also has a phone. And similarly over here, there is a user and there is a phone. Now, all of the data that is actually going to be sent out, this is your normal data. It can be anything, media files and so and so and so. And all of your data from your phone, this is probably going to be your voice traffic, right? So you need to prioritize, because when router is going to forward that traffic, the router is definitely going to forward the traffic just in a transmit where data is being sent, voice is being sent, voice is being sent, data is being sent, data is being sent. And then when it receives to the destination router, the destination router is just going to send that particular data and send that particular voice, right, like that. So when the host and the IP phone transmits data and voice packets destined to the host onto the other side, then it is likely that we get congestion on this particular link. You definitely might face congestion over here. And the router will queue the packets that are like waiting to be retransmitted or that are waiting to be translated, but the queue is not unlimited, right? So what should the router do when the queue is full? The router is definitely drop the traffic, right? But what traffic does router needs to drop? The router again does not have any understanding about whether this particular traffic is important or this particular traffic is important. And if the queue is full, both the traffic can be in the queue. Then when there is no space left onto the queue, which traffic to be dropped, whether to drop the data traffic or to drop the voice traffic. So when you drop voice traffic, the user onto the other side will complain about poor voice quality, right? But when you drop a data traffic, the user might complain that transfer speed are poor. So QoS is about using tools to change how the router or switch deals with different packets. For example, we can configure the router so that the voice traffic is prioritized before the data traffic, because it is latency sensitive data, right? Your voice traffic is assumed as best when it is like you can say, I would say sent into less than 150 milliseconds. Okay, otherwise there will be delay into listening and all these things. So you can say that there are 4 characteristics on a network traffic that you must deal with, or how you can categorize your traffic with. One, there is something called bandwidth, right? Then second is there is something called delay. The third one you have is called as jitter, and the fourth one is called as loss. So bandwidth definitely is going to be the speed of the link, right? And with the QoS, you can tell the router how to use this particular bandwidth. With FIFO, with first in first out, the packets are served on a first come first serve basis. And one of the things we can do with this with QoS is create different queues to put certain traffic types into different queues, right? So we can then configure a router so that the queue that actually gets like we have a Q1 that actually gets 50% of the bandwidth. And then we can also configure a Q2 that actually gets 20% of the bandwidth. And then you can also configure a Q3 that actually gets 30% of the bandwidth. That's how we categorize our total available bandwidth we have, right? And then we can specify that what kind of traffic needs to go into Q1, what kind of traffic needs to go into Q2, and what kind of traffic needs to go into Q3, so that the data is actually not sent collaboratively, and we take decisions sensibly that what traffic can be dropped or so. Delay, which is the other factor, is the time that it takes for a traffic to get from source to destination. Okay, this is called as the one-way delay, and the time that it takes from a source to destination and from destination to source to get the reply back, we basically call it as RTP, round trip, RTT, round trip time, right, or round trip delay. So there are different type of delay without you can say going in much detail, but there are different types of detail that are available. You have processing delay, you have queuing delay, you have serialization delay, you have propagation delay. You get to learn about these particular things into CCIE. But yeah, some of these particular delays like propagation delay is something that you cannot really change. So you can do, I would say, implement policies in order to specify that if like an application of a routing policy, if you remember that, we are basically prioritizing the traffic based on the jitter, based on the delay, right? Based on the loss. These are the values that are basically created or you can say used by BFDs, bidirectional forwarding detection. That's what it detects, right? So you can use delays, you can use jitter, you can use losses in order to prioritize your traffic in a way. Jitter is also a variation of one-way delay in a stream of packets. For example, let's say an IP phone sends a steady stream of voice packets, right? There are lots of packets that are going up in a stream. And because of congestion in the network, some packets are delayed. So the delay between packet 1 to packet 2 might be maybe 20 milliseconds, and the delay between packet 3 and packet 4 is 40 milliseconds. That probably can be the scenario. So the delay between packet 3, now you can say, or packet 5 and packet 6 is basically 5 milliseconds only. So you see how variation is over there. So the receiver of these particular voice packets, which is going to be this phone, must deal with the jitter. Okay, then making sure that the packets have a steady delay and you will experience poor voice quality over there. That's something which can be called as jitter. Your traffic is actually jittering. It's not coming in smooth flow. And loss is basically the amount of data loss that is there. So if you're sending like 100 packets and only 95 of packets are making it to the destination, you have 5% of packet loss. That's pretty easy over there. So by using these particular values, delay, jitter, and losses and all, you can basically, I would say, configure policies. Application and routing policy is one of the example over there, that you can prioritize your traffic via a single transport or prioritize your traffic via some other transport or so, taking these particular QoS components into use. Definitely, there are lots of other things as well, shaping and policing and all these other things, but these are none of our concerns so far, and that's how QoS actually can be understood.